By the end of this chapter, you should be able to know what a random phenomena means, know the basic probability axioms, and also understand the basic probability vocabularies. So we'll first start with what a random phenomena means. So a random phenomena is a situation in which we know what outcomes can possibly occur, but we don't know which particular outcome will happen. For example, if I have a coin, you all know that it's either going to be a head or a tail. That we all know. But if I toss the coin now, you cannot tell what is going to happen, whether it's going to be a head or a tail. So that is what a random phenomena means. Another example is also a die. You know, when you have a six-faced die, you know that you could either get 1, 2, 3, 4. So you know all the situations or all the scenarios that can happen. But if I roll the die, you cannot tell whether you are going to get a head. You are going to get 1, 2, 3, 4, 5, or 6. So that is what a random phenomena means. And so in view of that, let's try to do question 1 and 2 from the chapter 12 homework. So what do you think is the correct answer? D. Okay. Anybody else? Do you all agree it's D? Okay. Let's do 2, 2. What do you think the right answer should be? Anybody? So someone is saying A. Anybody has a different opinion? Do you all agree it's A? Why? So it's A. You know, when you roll a die, the chance of you getting 1 or 2, they are all the same. Is that okay? They are all 1/6. Does that make sense? Okay, so for the other problems here, we will be doing questions that are in the textbook. So we will do some problems in the textbook. So end of chapter questions. So you could open that too, because you have the textbook on Pearson. So in case the projector, like you're sitting far and you can't see the problems properly, You could read from your screen. So let's proceed. So now we've been able to understand what a random phenomena means. The next thing we want to talk about is some vocabularies. So we are starting with a trial. So each time we observe a random phenomenon, it's called a trial. So for example, each time I toss a coin, it's a trial. Is that okay? Each time I roll a die, it's a trial. Is that okay? And so when I toss a coin and then head appears, the head is the outcome. Is that okay? Does that make sense? Good. And so when we combine outcomes, we have events. And then it's very important because I've seen in your homework that sample space has been tested a lot. So what a sample space means is that what? A sample space is the collection of all possible outcomes. For example, if I toss a single coin, all possible outcomes, you are just going to get a head or tail. Is that okay? If I roll a die, the set of all possible outcome or the sample space is going to be 1, 2, 3, 4, 5, 6. Is that okay? If you roll 2 dice, the sample space is going to have what? 36. Is that okay? That first you get 1 and 1, 1 and 2, and those stuffs. Does that make sense? Good. So the sample space is the set of all possible outcomes. Does that make sense? Good. So this is the example just to explain what those definitions were. Now, it's very important for you to understand this. The probability of any event is the number of outcomes in A divided by the number of possible outcomes. So I recommend that you put this in your cheat sheet so that you know how to find the probability of an event. So in view of this, let's try question 5 and 9. For 5 and 9, I think I have typed it so we could be able to do this here. So let's try question 5. So question 5 says that in your dresser, there are 5 blue shirts, 3 red shirts, and 2 black shirts. So I want you to write down how many blue shirts do we have? So write that down. So write blue shirts equals 5. How many red shirts do we have? So write red shirts equals 3. And how many black shirts do we have? So write black shirts equals 2. Now I want to ask you one question. What is the total number of shirts? Do you all agree the total number of shirts is 10? How did you get 10? You adding all of them up. Is that okay? So now we are all okay with this information. We have the total number of shirts to be 10. Is that okay? And then we have blue shirts to be 5, red shirts to be 3, and black shirts to be 2. Are we all good on that? Now, question A. What is the probability of randomly selecting a red shirt? So to be able to get that, what is the total number of red shirts? 3. So look at the formula here. The total number of the total number of possible outcomes. So the total number of red shirts is what? 3. Divided by the total number of what? Shirts. So we are going to get what? 3 over 10. Does that make sense? That answers A. Any questions on A? So if I ask you, what is the probability of randomly selecting a blue shirt, a black shirt? What would that be? What is the probability of randomly selecting a black shirt? 2 out of 10. Because the total number of black shirts is what? 2. Divided by the total number of what? Shirts, which is what? 10. What is the probability of randomly selecting a blue shirt? 5 out of 10. Is that okay? Are we all okay on that? Okay. Let's get to B. What is the probability of randomly selecting a shirt that is not what? Black. How did you get 8 out of 10? Okay. So what he's saying is that he found a probability of finding blue shirt, which is 5 out of 10. So it means that either you select a blue shirt or a red shirt. So 5 out of 10 plus 3 out of 10, which gives you 8 out of 10. Is that okay? Or there are other ways you could do that. We would talk about complement. For example, if I say that the probability that it's going to snow today is 0.2, it also means that the probability that it's not going to snow today is 0.8. Is that okay? So those are complements. So you could also find a probability of a black shirt, which is 0.2, and then you find a complement of that. It's also 0.8. It's the same thing. So it's very important that you know how to answer this problem because you have an example of this in your homework. So then I wrote down the answers here. Any questions on question 5 so far? We all okay on question 5? Okay. Let's proceed to question 9. Question 9 is a bit lengthy, but let's do it step by step. It's very important that you understand it. Is that okay? Okay, let's do question 9. We are told that for each of the following, we should list the sample space. What is the sample space? Sample space is what? The set of all possible outcomes. Is that okay? And after listing the sample space, you should tell whether the events are equally likely. What that means is that when I list all this sample space, the chance of this happening and this happening and this happening, are they the same? If they are all the same, it means they are equally likely. Is that okay? So that is what the question is saying. Now let's start with A. We are tossing 2 coins. We should what? Record the order of heads and tails. The question is saying, let's list the sample space. So when you toss 2 coins, what are the possible outcomes? The first coin could give you a head, and the second coin could also give you a head, which is head and head. Is that okay? Or the first coin could also give you head, the second coin could give you a tail. Is that okay? The first coin could also give you tail, the second coin could give you a head. Or both coins are going to give you tails. Is that okay? So these are the what? The set of what? All possible outcomes. So this is a sample space. Any question on this one? Okay, now let's answer the second one. Are these events equally likely? Let's try to find the probability of each of them. Then we can be able to determine that. What's the probability of you getting a head and a head? The total sample space here is what? 4. Head and a head is 1, so 1 out of 4. Is that okay? Probability of you getting a head on the first coin, tail on the second coin is also 1 out of what? 4. Is that okay? Probability of you getting tail on the first coin, head on the second coin is also 1 out of 4. So because the probability of each possible outcomes here is the same, they are all 0.25. Is that okay? It means that what? The events are equally likely. If the probabilities here were different, they are not equally likely. Does that make sense? Any question on A? Okay. Let's get to B. B, a family has 3 children. We are told to record, so we've been restricted. Record the number of boys. Is that okay? So if a family has 3 children, we should record the number of boys. Before we do that, let us think about what are the possible outcomes that could happen. Is that okay? 3 children. There could be a situation where all those 3 children could be all girls. In that situation, the number of boys is what? 0. Does that make sense? The first one could be a boy, the other two could be girls. How many boys do we have? 1. Is that okay? First and second could be boys, third could be a girl. We have 2 boys. And then all boys, 3. Is that okay? So the number of what? If we want to record the number of boys, the sample space is going to be what? 0, 1, 2, and then 3. Does that make sense? Good. So these are the sequences I wrote down. I spent time to be able to write this down to explain to you so that when you are doing your homework problems, you could be able to look at this and generate your own. In case your homework problem is asking you, you should record a number of girls. You could look at this and then what? Generate your own sequence and then find your own sample space. So you see when you look at this, oh, all girls, it means the number of boys is what? 0. Is that okay? The first could be boy, the other 2 could be girls. That in that situation, we have only 1 boy. First could be girl, second could be boy, third could be girl. We still have 1 boy. First 2 could be girls, the last could be a boy. We have 1. Is that okay? Or first 2 are boys, the third is a girl. So the number of boys here is what? 2. First could be boy, the second could be a girl, the third could be a boy. We have what? 2. First could be girl, and then the last 2 are boys. So in those situations, the number of boys is what? 2. Or we also have all boys. So if we are asked to what? Write the sample space, the question is asking us to what? Record the number of boys. So the number of boys is going to be what? 0, 1, 2, 3. That is the sample space. Any question on this? So if we have been able to record the sample space, the next question we want to answer is, are these events likely? What is the probability that you are going to get 0 boys? Can somebody help us? What is the probability of you are going to get 0 boys? Why do you think it's 1/4? Okay. I agree with the 1, but I don't agree with the 4th because when I look at here, I see 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 8. Does that make sense? So the probability you are going to get was 0 boys is what? 1, 8. That means all girls. Does that make sense? The probability that you are going to get 1 boy is what? It's going to be what? 3/8. Is that okay? So you see, we're having 1/8, 3/8. Those probabilities are what? Different. They are not the same. And so this is what? This event is not equally likely. Does that make sense? So I spent time to be able to do that for you. So you see 0 boys, you getting all girls 1/8. 1 boy, either this or that, 3/8. Is that okay? 2 boys, this, 3/8. And then 3 boys is also 1/8. Now we have 1/8 here, 3/8, 3/8. For events to be equally likely, the probabilities here should be the same, like the first one, where they were what? 1/4 throughout. Is that okay? Yeah, it's not the same throughout. And so the events here are what? Not equally likely. Any questions? Do you understand how to generate the sample space? Okay. Let's get to C. C says that flip a coin until you get a head or 3 consecutive tails. And then we are told that record each flip. Now you are flipping a coin until you get a head or 3 consecutive tails. What are the possible outcomes? If I flip the first one, I get a head, I'll stop. Does that make sense? So that is 1. If I flip the first one, I get a tail, I'll continue. I flip and I get a head, I'll stop. Is that okay? You flip, you get a tail, flip again a tail, and then a head, you'd stop. Or you could also we are told that what? 3 consecutive tails throughout. So you flip tail, 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 you'd also what? Stop. Is that okay? Good. So this is what? The sample. So we are asked to find the what? The sample space. So this is the what? The sample space. Is that okay? Now let's try to find the probability of each outcome. What's the probability of you getting a head? It's 1/2. Is that okay? Probability of you getting tail and a head. If you toss a coin, the first one is 1/2, and then head is another 1/2. So this is what 1/4. Does that make sense? Now the first one, tail, is 1/2 times another tail, 1/2 times another head, 1/2, 1/8. So you can see the probabilities here are what? Different. And so they are not what? Equal. So not equally likely. Now let's get to the last one. We are asked to roll 2 dice. Record the larger number. You are rolling 2 dice. So if I roll the 2 dice and the first one is 1, the second one is 5, what number will I record? We are told that we are rolling 2 dice. We know that each dice has 6 faces. And I'm rolling 2 of them. And I'm told I should record the larger number. Is that okay? And I'm saying if I roll the die and then the first die appears 1, the second die, the number that appeared is 5, which of these 2 numbers will I record? Do you all agree it's 5? It's 5 because I'm asked to record the largest number. Is that okay? Oh, good. Okay, another question. If I roll the first one and it's 2, the second one is also 2, which number will I record? 2. Is that okay? Good. So we know when we roll 2 6-face dice, there are 36 possible outcomes. So this is what I took the pain to be able to write all the various pairs that could happen. Is that okay? So when you look at this one here, if I roll, I decided to know the number I'm going to record. If I roll the first one, I get 1, and the second one, I get 1, I'm going to record 1. Is that okay? Now, if I roll the first and I get 2, the second one, I get 1, I'm going to record 2. The first one I get 1, the second one I get 2, I'm going to record 2. If both are 2s, I'm going to record 2. Is that okay? So here shows the various pairs, and then this column here shows the number I have recorded. Is that okay? So now looking at this, what is the sample space? So the sample space is what? 1, 2, 3, 4, 5, 6. Because that is the number of what I'm recording. That's what you were told. It says that what record the larger number. So the sample space is what? 1, 2, 3, 4, 5, 6. Does that make sense? And then let's try to answer the question which says that what? Are these events equally likely? So if you get 1, there's only 1 here. So we know that when we have 2 dice, the total outcome is what? 36. So this is going to give us what? 1 over what? 36. If I'm recording 2, these are the possible options. 1, 2, 3. 3 over 36. If I'll just do these 2 and stop, because I'm just trying to answer the question, are these events equally likely? This is 1 over 36. This is 3 over 36. So they are not equally likely. Is that okay? But I went ahead to do all the possible ones. Is that okay? And to be able to do that, you can add all of them. You should be able to get 1. Okay? So this is how to answer these kind of problems. I think there are about 3 or 4 of them in your homework and your quizzes. So it's good that you understand them. And whenever you get confused, you could watch the lecture video and also look at the slides. Is that okay? And then try to learn how to generate this. It's going to help improve your understanding. And with that, you can be able to see how to do these stuffs more easily. The next thing we want to look at is the rules on how probability works, or the probability axioms. So it's very important that you also write this in your cheat sheets. So the first one, you should always know that the probability of an event, or the probability, is a number that is between 0 and 1 inclusive. There is nothing like a negative probability. Is that okay? There is nothing like a negative probability. And there is no probability that is going to exceed 1. It's always between 0 and 1. So for example, if I say that the probability that it's going to rain today is 0, it means that it's never going to rain, and I'm so sure about that. Is that okay? The probability that it's going to snow tomorrow, if I say the probability is going to snow tomorrow is 1, it means I'm so sure that it's going to snow tomorrow. Is that okay? And then there is also in between. It could be 0.2, 0.1, 0.4, 0.5. But always know it's between 0 and 1 inclusive. Good. And then 2, the set of all possible outcomes of a trial must be equal to 1. So the probability of the sample space is always equal to what? 1. For example, when you are tossing a coin, head gives you 1/2, tail gives you 1/2. When you add them, you are going to get what? 1. Is that okay? So you should always know this. And then always know the complement rule. It's very important. You can use this complement rule to answer even the first one that we did here, when we are talking about the black shirt. Find the probability it's black. 1 minus that gives you the shirt is not black. So it's the same thing. So the complement rule is saying that, so the C here stands for what? A complement. Some textbooks use an apostrophe or comma or something, but I'm using a C here just to stand for complement. What complement means is that, for example, if I say that the probability that it's going to rain today is 0.2, the complement that the probability not going to rain is what? 0.8. Does that make sense? So just know this. So the probability of an event not occurring is the same as 1 minus the probability of it what? Occurring. That is what the complement rule says. And then we also have with what we call disjoint sets, or sets disjoint probabilities or disjoint events. It means that they have no outcomes in common. Is that okay? And so if you have 2 events that have no outcomes in common, it means the probability of A or B is the same as probability of A plus probability of what? B. It's the same when you are answering when the shirt is not black. That is what you did. Is that okay? And then we also have what we call independent events. So independent event means that 2 events occurring that they are both independent, which means that the chance of this occurring has no impact on the other one. Is that okay? And so when it happens that way, for us to find the probability, we can multiply probability of A times probability of what? B. So it's very important you know this. And also try to write this in your cheat sheet. The probability of A union B is given as this. This probability of A intersection B, this is what the disjoint sets come from, because they have no events in common. So here is what? 0. That is why here you see is P of A plus B. Is that okay? Good. Now let's try to answer questions 19. So you could open your textbook, go to chapter 12, end of chapter problems, and then let's go to question 19. So I have 19 here. This is also in your homework problems, but if you can't see from where you are sitting, you could open them on your screen. It's the same end of chapter problems. So this is question 19. And we are asked to find which of the following probability assignments are legitimate. So they are trying to test you to be able to find which of these ones here satisfy the rules of probability. Is that okay? So I have broken this into 3 parts. Try to, whenever you are faced with problems like this, try to answer 3 questions. So when we have this, we can see this is what? A. So it goes row. So A that way, and then B, C, D, and then E. Does that make sense? So we are going horizontally. Is that okay? Good. So first and foremost, to be able to answer if these probability assignments are legitimate, rule number 1, let's look at A. Is there any negative probability in A? Look through red, yellow, green, blue. Is there any negative probability in A? No. So rule number 1, passed. Is that okay? Number 2, is there any probability in A that exceeds 1? No. Passed. Is that okay? And then the third one, try to add all these and then see if you are going to get 1. Is that okay? So if you add 0.25 plus 0.25 plus 0.25 plus 0.25, what do you get? 1. So when you add all, you should be able to what? Get 1. Is that okay? And so A is legitimate. Is that okay? Let's get to B. Is there any of the probabilities, red, yellow, green, blue, that is negative? No. Any that exceeds 1? No. Okay, so 2 rules passed. Now the third rule, try to add all of them and tell me, when you add all of them, what do you get? You get 1? Okay, so rule number 3 passed. So this is also what? Legitimate. Is that okay? Let's get to C. Anyone that is 0, that is negative, that exceeds 1? No. So add all of them and tell me what you get. When you add all, what do you get? Did you all get 1.4? 1.4 exceeds 1. Is that okay? So C fails. Does that make sense? So C is not legitimate. Let's get to D. So now that you know how to answer them, look at D and tell me whether it is legitimate or not. How many of you think it's legitimate? Just show by your hands. How many of you don't think it's legitimate? How many of you don't know? Okay. So D is legitimate. Probability can be 0. Is that okay? It can be 0. It can be 1. It can be 0. When you add all this, you are getting what? 1. So D is legitimate. How about E? Why? Because of the negative. You don't even need to go further. Is that okay? Good. So that is how to answer questions like this. Let's get to 23. What do you think is wrong with the reasoning? So when we look at 23, we are told that the traffic checks on a certain section of the highway suggest that 60% of drivers are speeding there. Is that okay? Good. And then it goes on to say, since 60%, so you can see 0.6 equals 36. The multiplication rule suggests that there is a 36% chance of two vehicles in a row speeding. What is the multiplication rule? We can see that this is the multiplication rule. Is that okay? For this to happen, it means the two events has to be what? Independent. Is that okay? For you to be able to or comfortably multiply those two speeding events, it means that they have to be independent. Now, you ask yourself, when two cars are driving, are their speeds independent or not? It is dependent because even in traffic, how you move depends on the one in front of you. Does that make sense? Independent means that whatever this guy is doing shouldn't impact me. Does that make sense? Even if you're on the freeway and you even want to go speed and the one in front of you is not speeding as you want, his driving or his speed is affecting or is limiting how you want to drive. Does that make sense? And so that is not what? Independent. Is that okay? And so we can say that when two cars are traveling together, their speeds are not independent. Is that okay? So independent, you have to understand the word independent. Independent means that this one is not affecting this one. But when two cars are traveling together, their speeds are not independent. Does that make sense? Good. So then the multiplication rule, since they are not independent, the multiplication rule does not apply. Is that okay? Good. Let's try one more example. Let's get to 33. So we are trying question 33. So when we read 33, it says that a Gallup poll in March 2013 asked 529 US adults whether increasing oil, gas, and coal production or developing alternative energy sources such as wind and power should be given a higher priority. And so this is the summary of what the response. Is that okay? So what it means is that for oil, gas, and coal, 164 people, and then no opinion, 16. So the total respondent is what, 529. Is that okay? Now the question is asking, question A, if we select a person at random from this sample of 529 adults, what is the probability that the person responded increase oil, gas, and coal? So to be able to find the probability of something, we know that what? The number of what? Divided by the total. Is that okay? So you can see A, what is the number of people who support increase oil, gas, and coal? They are what? 164. Is that okay? So that answer will be what? 164 divided by the total number of what? Respondents, which is what? 529. Is that okay? So A is 164 divided by 529. So now I'm leaving B to you. So tell me, what do you think B should be? Do you agree it's 53 over 529? Okay, that's correct. So how did he do it? What he did is that he decided to say, what is the probability of what equally important? 37 over what? 529. This or here is the same as plus. Is that okay? Plus no opinion. No opinion here is what? 16 over what? 529. Is that okay? And when you combine them, you get 53 over 529. Any questions? Okay. If you have no questions, would end here and then would continue on Friday.